So pick up your colored pens. Of course, you already have your calculator out. So how much would the TV have to cost for it to be worth it to drive to the other town? Start with Jada, Sebastian, Brian, Zabari, Sharik. What'd you get, Jada?
I got 2.
Go ahead.
I got 10.06 but it's going to be $6 for the extra. $6 for the drive.
Okay, so what you did was you presented two possibilities, but then said neither of those possibilities would make sense. Which is I like the process that you're going through. That's what I was hoping many of my students would do, that process. But I wasn't looking for a yes or no. I was looking for an actual number that would work. Okay, but you were on track. That's excellent, Sebastian.
It would have to be $1 less.
It would have to be what?
$1 less.
It would have to be $1 less than what? Your answer tells me that you didn't quite understand the question, because you've got two towns and the TV's being sold for the exact same price in both towns. So if the TV is being sold here for $50, it's being sold here for $50. If it's being sold here for $100, it's being sold here for $100. The difference is not the price of the TV. The difference is the sales tax. Okay? Here, then here, here, and then I'll come back to Kamori. Just tell me what you got.
No, I realized it was wrong, but I figured out the right answer in my head. Okay, I got 2. For the price to be same in both cities, it had to be 600.
Okay.
And for it to be greater in, less expensive in Royal City than Sandy Cove would have to be $601
Mm-hmm.
or more.
Okay. Okay. Zuar? Huh?
$610.
$610. Okay.
I got $600.
$600. What'd you get, Kamori?
No, I was gonna say I didn't get it, but I was gonna say like it makes no sense because like if sales tax is 6% and getting COVID is 7% in Royal City, wouldn't it Royal City always cost more because of sales tax in there?
That's a very good point. Could someone respond to her statement and tell her what she missed that makes this an interesting question? Catalina?
That if you have to go to Sandy Cove, you have to pay $6 more.
You have to drive. Look at the the third sentence. I'll read from the beginning. You are a resident of Royal City. In Sandy Cove, the sales tax is 6%, and in Royal City, the sales tax is 7%. So you're right. If the price of an object is the same in both cities, then where you live is always going to be more expensive than the other town. Right? So it seems like it would always make sense to go to the other town to buy it. However, it costs you $6 to get there. It costs $6 to drive round trip between the two towns. So a $10 TV, and of course there's no $10 TV, but we're just making up something. A $10 TV will cost $10.60 in Sandy Cove, $10.70 in Royal City. Would you make a drive to save that 10 cents? Well, if you were super crazy frugal, you would. However, and there are people who do that, however, it costs $6 extra to drive there. So it's not costing you $10.60, it's costing you $16.60. So then would you drive? No, then it wouldn't be worth it. So my question is, how much would the item have to be for it then to become worth it? Okay? Any other answers? We've got quite a few proposals. And? Less than $112, okay. Alyssa? 601 or more. Okay? Interesting. Correct answer is $601, and of course, or more is correct. And I'll accept more answers. You said 600, so you can mark yours correct because you got the basic idea. Although, if it's $600, it's exactly the same price in both places. So really, it has to be 601 for it to be worth it to make the drive. So, I'm not saying this is easy, but what I'm saying is there was a process that you should have gone through to try and figure some things out. First of all, let's iron out a few basic details. When I'm working with 6%, how do I write it? Like when I'm going to work with it or type it in my calculator, how do I write it? Kezekiah?
0.06.
Okay, so we've got Sandy Cove, and I'm just going to shorten that to Sandy. You're going to be working with the number 0.06. And in Royal City, you're going to be working with the number 0.07. So that's just a basic understanding of how percents work. If you want to figure out how much tax you pay on an item, a $10 item, you multiply the rate times how much it costs. But we don't know how much it costs. It's missing. So if we multiply it times that tells us how much tax is involved. Okay? But the problem is that you don't just pay tax for an item. In other words, if I want to buy a $100 item times 0.06, do I only have to pay $6? How much do I have to pay, Ania? So you have to add the tax onto the original amount. So now look at what I wrote here. This is going to tell me the tax. This is the original amount. So I have to actually add n plus this amount, and that tells me how much total I'm going to pay. Yes, come on.
My mom had me go just use this and multiply by 1.06.
Very good. So that actually leads us to a really fantastic shortcut that everybody in this room should master. Is that if you're going to take the percent of something and then add it on, the shortcut is just change this to a 1.06 because this is really 1n, and 1 plus 0.06 is 1.06n. And that will not only tell you the tax, it will tell you the total amount of money, which will also work for Royal City, which is going to be 1.07n. So Kamoy made a fantastic statement, which was, no matter what the price of an item, this is always going to cost more. But Catalina pointed out the important detail, $6. So I have to account for the $6. So now we're saying plus 6. When will this become less than this? Now, we haven't learned inequalities yet. So I would never have expected you to use an inequality, but I would have expected you to make some sort of equation or maybe a table or something like that to figure it out. And I did see that a lot of people putting like a few made up values, like some people said, okay, $10, $50, $100. Let's see what would happen. And you guys wrote it down and you kept trying. That's called trial and error. That's fantastic. That's what you're supposed to do. But what your goal, being a member of my class, is to be able to get your brain to see things like this. This is what makes you an Algebra 1 honors student and not just an advanced student. Okay? So I don't expect that you were able to do exactly this right now, but this is what we're working towards. Does anyone have any comments or questions? Ania? Why? Solve this equation. A $600 TV? By today's standards, $600 is pretty cheap, actually. Okay, so we'll get you a dinosaur TV. The rest of us are going to opt for the really fancy LED flat screen TVs. Okay? And Brian, for the $601 TV, how much will it actually end up costing us?
Wait.
Well, I did.
You wrote it down and circled it. I saw it on your paper. How much?
$643.
$643. With the money you have to spend on travel and the 6% sales tax, the $601 TV will cost you $643. Who said that? Yeah, it's in 6 or 7 cents. That's right. Very good. Okay. Comments or questions? Put the warm up to the side. Over the last few lessons, I've started out by talking about how we've been building on top of what we learned previously. And we're still going to do that. I also made reference a few lessons ago that we were going to make a big leap. And then the next time we had a class, I said, well, this isn't a big leap, it's more of a moderate-sized leap. The last lesson, the percents lesson, was kind of like a little side trip. That wasn't a leap, that wasn't even really moving forward. That was like a little side trip, and now we're back. And today we are making a huge leap forward. I'm telling you right now, many of you are going to struggle with what we're going to be going through, what I'm going to be modeling, what we're going to be discussing. It is a big leap. This is where things change for the rest of the year. Today is where we establish the skills you need for everything else that's already up on my back bulletin board and that will be later on in the year. So we're going to be talking about formulas and functions, but we're going to be talking about what are called literal equations. A literal equation is an equation that has 2 or more variables. And we're not going to be solving the equations. You're going to be learning how to rewrite an equation. You're going to use all of the same skills you've learned, but you're going to be forced to think differently about what you're looking at. Don't worry, I'm going to demonstrate everything, and eventually you will get it. But it is not going to be instant. And there's many people in this room, some of you gifted, some of you very advanced, who are used to things being instantly understood. It is not going to be like that today. If you're struggling, if you just don't get it, don't say, I don't get it. Don't just say, what? Just give it a little time. Keep going. Follow along with me, and it will start to click. So again, a literal equation is an equation that contains 2 or more variables. A formula is basically an equation that's used in real-life situations. You've memorized a whole bunch of them already, and I've got 4 new ones up here for you to memorize. So all of these equations that we use, all of these formulas, can be rewritten in different ways for different purposes. That's something you're going to be learning today. This is the biggest concept of the day, function form. When we take a 2-variable equation and rewrite it so that one of the variables is isolated, that's called function form. For example, if we want to rewrite 3x plus y equals 4, that's an equation with 2 variables. If we want to rewrite it so y is a function of x, that's a very fancy phrase that you will get used to starting today, then this is what it's going to look like. Y equals negative 3x plus 4. I am not teaching you yet how we got from here to here. All I want you to see is our goal. Our goal is to learn how to get the y isolated by itself. Excuse me. Okay, Brian.
Is function form related to slope-intercept form?
It's related, yes. You will, in chapter 4, start learning that function form and slope-intercept form are really the same thing. But right now, it's a more generic idea, and so it's called function form. Another example, doesn't have to be x's and y's, it could be any two letters. 2v minus w equals 10, and we want to rewrite it so v is a function of w. There's that phrasing again. Something is a function of something else. So what will that look like when we achieve our goal? V equals 1/2 w plus 5. So again, I am not teaching you yet how to get from here to here. You're going to learn it in about 10-15 minutes. But this is the goal. Our goal is to learn how to get this v by itself like that. Ania?
These equations aren't meant to be solved.
Nope. They are not meant to be solved in the sense that you understand the word solve. When we say solve, up until today, that meant find a number, right? Find a number that makes it true. Starting today, we're not going to do that. I mean, you're going to do it on a test or you'll do it in the future, but starting today, our goals are now changing. So, Ania, that was a great point that you just brought up. Solving, it doesn't really have the same meaning anymore. So, we're going to get to function form a little bit later. We're going to start today with formulas. So, example 1. So I am going to teach you how to accomplish our goals by using what you already know. And I'm going to do it in not an unusual way, but in a particular way. So what I would like you to do is set up your paper. Let me change that. Set up your paper into 2 large columns. Something like that. We're going to actually do the question twice. My left-hand column, I am calling do this. You'll understand why in a moment. My right-hand column is called think this. And so what I'm going to do is I'm going to actually make up a whole different equation that you will find very familiar. And I'm going to use that equation to help you see what you're supposed to do. So, I'm going to rewrite the original question. You don't have to rewrite it. So, S equals 2B plus PH. And our goal is to solve for B. So at the end, I want it to say B equals something. I don't know what it's going to say. We have to figure out how to get here. I am going to make up a completely different question. So here is my completely different question. 10 equals 2b plus 2 times 3. So we are going to be focusing on the green for a moment. What would the first step be in solving this? I should see 90% of the hands up. And? Okay, what's 2 times 3? Okay, so you don't even actually need to do it because you just know that 2 times 3 is 6, right? So I could rewrite it, but let's leave it like that for a minute, and you'll understand why in a moment. But you know in your head that that is a 6. So I'm not going to rewrite it as a 6, but in your head you're saying to yourself, that's a 6. So now what's the next step? What's the next step? Alyssa?
Subtract 6.
Very good. She's catching on to what I'm saying. So I'm going to subtract 6, but watch what I'm going to do. I'm not going to do subtract 6. I'm going to say subtract 2 times 3. Because isn't that really subtracting 6? And now I'm going to do that over here. Subtract 2 times 3. And then I draw my elementary school squiggle line. This disappears. And now I'm not going to simplify this. I want to show you what it will say. 10 minus 2 times 3 equals 2b. So the key was that we had to do the inverse of this right here. So now, let's apply that same idea over to the real equation on the left. Let's see who's catching on. What am I going to do? What's my first step? I got 1, 2, 3, 4, 5, 6, 7. I got a bunch of people who think they're catching on. Maria?
Subtract p times h from both sides.
She definitely is catching on. We have to get rid of this because it's being added to the b. We have to get rid of it first by subtracting ph from both sides. Elementary school line, it disappears. And now you should see why I did not actually simplify this, because you can't simplify this. S minus ph equals 2b. Does anyone have any questions so far? Shelby? Nope. Okay, back to the green. I am still trying to get the b by itself. How do I finally get the b by itself? What am I going to do now? Eliana?
Subtract 2 from both sides.
Subtract 2. You're on the right track, but you missed one little detail. What operation is being done right here? Okay, so we don't subtract, we divide. Very good. We do the inverse, so we're going to divide by 2. Here's something that you did not learn yet that you're going to start right now. We're going to divide the other side by 2, but when you divide the other side, you have to divide everything by 2. So you have to do this. Watch carefully. Divide this by 2. Divide that by 2. This will disappear. Now we have the b by itself. If I wanted to know what b was equal to, I could simplify this whole thing and I would have the value for b. But my goal is not to solve this. My goal is to understand the transformations. My goal was to understand this and this. So now back to my blue side. What's the next step we're going to take? Next step. Sebastian?
Divide 2 for everything.
Divide both sides by 2. So we're going to divide by 2, and now I'm going to divide by 2, divide by 2. This will cancel out, and now I have my b isolated. Now my formula has been rewritten. So, get rid of this, rewrite it. We write the isolated variable on the left. B equals S divided by 2 minus PH divided by 2. Kamoy and then Brian.
That looks more complicated than what we started.
I'm sorry?
That looks like more complicated than what we started.
The formula.
Yeah, the answer looks more complicated.
This formula looks more complicated than the original formula. So you're wondering why would we do that? Okay, you're going to see in a little while why we would do that. I'm going to give you a different example that will hopefully illustrate it. Okay?
Wouldn't it be easier just to write s minus ph over 2?
In some cases, yes. And so here's my general rule. When you're rewriting a formula, you're trying to make the formula easier. So Kamoi's point is actually a good point. This now looks more complicated. So if you wanted to write it as b equals s minus ph over 2, you could write it like that. But there is a very important reason why I'm asking you to do it like this, and you'll find out in about 15 minutes why. Okay? So be patient with me. And then when we're done and we've learned everything, I'm going to leave it up to you to know when you're supposed to write it like this and when you should write it like this. Okay? Very good. Both of you made very good points. Okay? Are there any questions on the process? So my hope is that you're seeing that we're using the same exact skills we already know, just applying it to letters instead of numbers. So let's see if we can apply it again. And here's an excellent example that will hopefully answer Kamoi's question, which is solve the formula f equals 9/5 c plus 32 for c. This time I'm not going to do it twice. We're going to only do it once. I'm going to rewrite it just so I have a little more space. You don't have to rewrite it. F equals... Does anyone know what this is a formula for? Because I didn't tell you this time. Sharif?
This is the Fahrenheit formula.
Right. What will it do? In its current form, what will it tell us?
Okay, it will, in its original form, in its current form, it will tell us how to convert the temperature from Celsius to Fahrenheit.
That's right. If we have a Celsius temperature, you plug it in, crunch it out, and then you get the Fahrenheit temperature. But what if I wanted it the other way around? Right? Because here in the United States, we are usually given the Fahrenheit temperature. So we could, if we wanted to, just plug the Fahrenheit temperature in here and then solve the equation. But if you have to do that type of calculation over and over and over again, you want the formula rewritten so it's much easier for you. So we are going to rewrite this formula. I am going to draw my T. At this point, you should be able to decide for yourself if you need to or not. And let's see who's really catching on. Where am I going to start? Let's put it this way. What should my eyes be looking at right now? Where should I be focused? Tristan? Good. You said that beautifully. You have to get rid of addition and subtraction first, so I am looking right here, and I'm doing exactly what he said. Subtract 32 from both sides. But when I work down, this cancels out, but I cannot combine these. These are not like terms. So I end up with f minus 32 equals 9/5 c. I'm still trying to get c by itself. How am I going to accomplish that? And give me a second because I have not left myself enough room. Move this over. So what should I do now to get the c by itself? A little less confidence? Eric? Okay, so multiply. So what am I going to actually do? Multiply by? Yeah, I'm going to multiply both sides by the reciprocal of this. That's how we get rid of a fractional coefficient. But you now have to be extremely careful. Because when I multiply the other side, what do I have to do before I write down my 5/9? Something I got to do, otherwise I'm going to get the whole thing wrong, even though I put in a good effort. And? I'm sorry, go ahead.
Repeat the question.
We're going to multiply 5/9 times both sides. This is going to cancel this. And now I have my C equals. But I have to multiply it by this side too. It's something I have to be careful of. What do I have to be careful of? I thought you had your hand raised. I apologize. It's my fault. Brian?
You have to multiply the 5/9 by half.
Okay, actually, you presented the problem, the issue. So we're not just multiplying by f. You have to multiply by the entire side. So you have to put the whole thing in parentheses, otherwise it is not correct. And so you have two choices. You can leave it like this, or you could distribute if you wanted to, but 5/9 times 32 is going to probably be very ugly. So I wouldn't even bother. I would just leave it like this. 5/9 times f minus 32 is equal to c. And so our rewritten formula is c equals 5/9 times f minus 32. And that is how we rewrite a formula in a different form. So again, Kamoy asked a question. Well, this looks a little bit uglier than the original one, although this one's not nearly as bad. But so why would I do this? Well, if I am working in a field or a scientific situation where I'm constantly converting Fahrenheit to Celsius, and I constantly need this formula like this, then it's beneficial. If I only have to do it once, then I don't need a new formula. But you might, okay? Comments or questions on this?
So, like, if you're doing the homework and it says to rewrite the formula, it's going to be an actual formula, right?
Mm-hmm.
So, will there ever be times where it asks you to, like, plug in numbers to solve it?
It might. Some real-world scenarios, you'll be asked to rewrite a formula and then use your rewritten formula. But that's easy for you guys. Okay? Hezekiah and then Kamoy. This will convert from Fahrenheit into Celsius. Because if you plug in a Fahrenheit temperature, you subtract 32, multiply it by 5/9, and you will get the Celsius temperature. Okay? Kamoy?
Like what Andrew said, in example A, like, life is more complicated. In the real world scenario, and after you like rewrite the expression and stuff, can you just, when you're actually going to solve it, can you just use the old one?
Yeah, but I don't think I would ask you to rewrite a formula that made it much more complicated. I picked this one on purpose because it allowed me to show something the way I wanted it to. I don't know if I would ever ask you to rewrite that formula like that again. Okay? All right. And part C. Anyone know what this formula is? Oh, we got a whole bunch of people who know. Kayla?
The interest formula?
Yes, but there's different kinds of interest. This is the simple interest formula. It's very basic. It's I equals PRT. So we want to solve it for T, which means that I have to get rid of this and this somehow. How do I get rid of it? Sebastian? Yep. You can do it all in one step. Divide both sides by P times R. That cancels out, and you are left with the formula T equals I over PR. And so if you were in a position at a career, a job, where you were constantly having to find the amount of time based on information given to you, you would want the formula in this form, not this form. Okay?
Last year, at the end, around the end of the year when we were doing this so much, why didn't Miss Cooper teach us that formula? It's so much easier.
Which one?
The new one we just did.
This?
Yeah.
You were using the
No, we use I equals P or T, but not T equals I over P.
Right. Well, at the time, she was probably more concerned with you solving equations, not being most efficient. Kind of depends on what the goal is. Okay? All right, I got to move on because I want to make sure I finish everything. So, checkpoint number 1. I gave you a tough one on purpose. Got 2 minutes. Finished?
Well, sort of, but we don't write a 1/2.
So you got the right idea, and I bet that a lot of people do the same thing you did, but that's actually not the way you're supposed to do it. It's not really appropriate to put a fraction in the denominator of another fraction. Something else you were taught to do with numbers like that. Okay, pick up your colored pens. This is a little bit hard to get volunteers for because there's a lot of different answers. So I'm going to reveal one answer and then we'll talk about some possibilities. So this is the best answer. 2 times the quantity S minus B over P equals L. That's the best answer, but I want to show you what a lot of students did. And I knew that a lot of you would do this, and I'm trying to get you to think through something. So let me start. S equals B plus 1/2 P times L. So could someone tell us what was the first thing you did? I think almost everybody did the same first step. Maria?
Subtract 1/2 times PL both sides.
Well, that would be really great, but that would solve for B. We're trying to solve for L. So we want L to stay, and we want everything else to disappear. Alicia? Yeah. In this case, Maria, we want to subtract the B from both sides to get rid of that. This will disappear, and that's where we get the S minus B equals 1/2 P times L. Now, Catalina, you did something I want you to share because there was a bunch of other people who did it as well. What was your next step?
I divided 1/2 P over on both sides, but I did S over 1/2 P minus B over 1/2.
Right. So we divided both sides by 1/2 P, and you got this on both sides. Okay, and it's not horrible. It's not horrible. The formula will actually work, but here's the problem. We never, unless you are way up in college doing really advanced stuff, we don't put fractions inside other fractions. This is a big fraction, and then you guys put a fraction in the denominator. We don't do that. So there was something else that you were supposed to do. So let me rewind. What were we supposed to do to get rid of that? What were we supposed to do? Sharik?
You were supposed to multiply both sides by the reciprocal of a half. Which
That's right. Multiply by 2 over 1. Multiply the whole thing by 2 over 1, which is the same thing as multiplying times 2. So that's where I got this from. Then the last step will be divide by p, and that's where we got that from. Okay? So those of you who did what Catalina described, you're not a horrible person. You didn't do anything terrible. It was a good idea. It was very similar to what I showed you. But I want you to understand that we don't write fractions in the denominator or numerator of another fraction. Okay?
After you finished looking at my answer, I changed it, and is it okay if like you didn't do the 2 times the whole thing, and you just did 2 times s minus 3 times?
Unfortunately, it is different. So this would actually be incorrect. Because in this case, the 2 is being multiplied by the s. What's the 2 being multiplied in this case by? Ania? Yeah, this is distributive property. You would be multiplying by both. So the only other option would be, if you wanted to do that, you would have to write a 2 right here. So it would have to be that.
That's what I said.
That is?
Yeah.
I apologize. My mistake. Then you are correct. Ania, Alicia, Sebastian, and then I got to move on.
I wanted to ask you this.
Go ahead.
I put b minus s over p.
Can't be b minus s. The b is negative. You made the s negative somehow. Okay.
If you can have half b, can you have 0.5 b?
You can, but then you're breaking my other rule of I said don't change fractions to decimals. But you're right, you could have done that. Okay, so now here's the big jump. Function form. So the biggest difference in my mind, what I'm going to ask you to do now versus what you've done for the past 2 weeks, is your focus. So we're going to rewrite the equation so that y is a function of x. This is a very fancy way, this phrase is a very fancy way of saying isolate y. Whatever letter comes first is the letter that's going to be isolated. So if it says, so that b is a function of a, b is the one that's isolated. If it says z is a function of y, then z is the one that's isolated. Whichever letter comes first is the letter you're going to isolate. So here's what your focus becomes. Find the side that has that letter. So someone tell us, which side has the letter that we're trying to isolate? Tristan? The left. So you should only be doing things to the left-hand side. You should not be doing anything to the right-hand side. To isolate y, we have to get rid of this, and we have to get rid of that. You already know how to do that. You just have to learn how to apply it correctly here. So, how do we get rid of those things, and what is the first one we're supposed to do? What's the first thing we should do? Hold on 1 second. Let me organize myself. What's the first thing I'm going to do? Eric and then Sharik.
Get rid of 6x.
Yeah, you have to get rid of anything being added first. So we're going to get rid of the 6x by subtracting it from both sides. This will disappear. That's what we wanted. We wanted it to disappear. And we have the 6y left equals, and now I'm going to rewrite this whole thing. One thing I'm going to ask you to start getting used to is take the x and put it first. It's going to take you a little getting used to, but take the x and put it first. So this is negative 4x, and that's a negative 6x. That's negative 10x. This is a plus 14, plus 14. Yes? I did. The x term. Not the letter x, the x term. Whatever term. This is a term, and this is a term. We want the x term to come first. Brian knows why. He'll explain in a few minutes.
Oh.
The x term should come first. Okay, but now we got rid of the first thing. We still need to get rid of the 6. How do we get rid of the 6? Sharik was next.
Oh, to get rid of the 6, you have to divide both sides by 6.
That's right. And now you're going to see why I did what I did with the first example. We're going to divide by 6, but watch what we're going to do. We could go like that, but we're not going to because that won't put it in simplest form. We want to do this divided by 6 and this divided by 6. So basically you're dividing everything by 6. This will disappear and I'm left with y equals negative 10 sixths x plus 14 sixths. That's some great work we did. If we circle that right now, we will get it marked wrong. Because it has to be in simplest form. So I need some help with this, and I need some help with that. What is negative 10 sixths really equal to? Brandon?
Negative 5.3x.
That's right. So in actuality, this is y equals negative 5/3 x plus, and then what's the second number equal to? Hezekiah?
I know what it is.
Okay, Alyssa's going to help you. 7/3. Very good. This is simplest form. Does anyone have questions? Brandon, Ania.
Does that have something to relate to y equals mx plus
I don't know. Brian, does it?
What?
Ask your question again.
b? Is that y equals mx plus b?
Yeah.
They just said it.
He just said it.
So that's why I said you need to start getting used to putting the x term first, because eventually this function form will turn into slope-intercept form. Ania, why does it have to be mixed numbers? It's not mixed numbers. That's an improper fraction, and that's an improper fraction.
I meant improper.
It doesn't have to be. Well, let me say this. This we want like this. This doesn't matter. But for now, just leave it like this. We're not going to worry about that yet. Right now, I'm just trying to teach you how to rewrite in function form. So let's do part B. So our instructions are the same. We want to rewrite so that y is a function of x. But it's a bit more of a mess, and we have to simplify before we solve. That's what Sharik would tell you. We have to simplify before we solve. It's the same thing if you're rewriting, you simplify before you rewrite. So we're experts at distributive property at this point. 4x minus 8y equals negative 20x plus 2y. I'm sorry, that's not right. Minus 40y. So what is the difference between this example and the one that came before it? Tristan knows because I called on him for the last one. Go ahead. Okay, that's one major difference. We took care of that. Now look at the second line. Now what's the major difference between this and the one that came before it? Kamoy?
There's 2 y's.
Yeah. We're trying to isolate y, but there's a y on both sides. So in the previous question, I called on Tristan and he said we work on the left because that's where the y is. But now we have a y here and we have a y here. What do you think we need to do? Well, we got a lot of people who think they know. Shelby? You just have to say it. Good, but we actually have to do something to get them together. Jada, what do we have to do? Okay, which one's the smallest one? Good, and we're going to subtract it? Yeah, we're going to do the inverse of the smaller coefficient. So we're going to add 40y to both sides. That's going to disappear, which is what we wanted to happen. But here's what we're left with. 4x plus 32y equals negative 20x. Don't lose sight of the goal. The goal is to get the y by itself. So this is going to stay. This has to disappear. Which one's got to disappear first? You sure, Kezekiah? Kezekiah, go ahead.
Divide.
Okay.
Divide 32 by both sides.
Well, that is a step we're going to take, but we're not ready for that yet because there's something else we have to do first. Anissa? Subtract 4x from both sides. We have to get rid of that first. This disappears. 32y equals negative 24x. Now, Kezekiah, what are we going to do?
Divide the 2 by both sides.
Divide both sides by 32. This will disappear. And now I have y equals negative 24 over 32x. And if I did that, that's some great work. And then I would get it marked wrong. So Zabari, what do I got to do?
What?
Well, you're on simplify. Good. Ania, how? How do I simplify it?
Divide the denominator by 8.
Very good. Both divisible by 8. So this will be negative 3. That will be a 4. And so that is simplest form. Any questions on how we did that? Shelby? Okay, up here, these are not like terms. Like terms, these are on opposite sides of the equal sign. If you have this equal sign, now we have a left side and the right side. The x and the y are not like terms. You can't combine those. And you had said we have to combine this and this, right? But they're not on the same side of the equation. You can't combine them unless they're on the same side. So we have to get one of them to jump to the other side, and that's what we did with this right here. And then we did the same thing with this right here.
Yeah, I was just wondering. Simply to do it
The same time. You could do it at the same time. My really advanced students can do both of those steps at the same time. Okay? Good. So let's see how you do on your own. Checkpoint number 2.
Whoa.
one big long fraction bar and you do each individual part.
All right, colored pens up. I'm going to actually, for today, just reveal answers. I'm running low on time. I want to make sure we finish everything. So here's what I was looking for. Y equals 12/7 x plus 5/7. So, quite honestly, it was almost the exact same question as the one we just did. Actually, it was a tiny bit easier. The last question had x's and y's on both sides. Took a little bit more work. So y equals 12/7 x plus 5/7. Give me a thumbs up if you got it correct. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, put your thumbs down. Okay, what did you get, Eliana? Okay. Were you just not sure what to do, or you got stuck?
I stopped at 5 plus 7y equal negative 12x.
Okay. 5 plus 7y. Well, first step should have been 5 plus 5y equals negative 12x plus 12y. And then you subtracted 5y from both sides. Subtracted 5. I already know what some of you did. You didn't do distributive property right, correct? So this cancels out, and you got 5 equals negative 12x plus 7y. That's what you were talking about? So, again, I keep saying something similar, which is don't lose sight of the goal. The goal is to get the y by itself. Here's the y. If I want the y by itself, what do I have to get rid of? Alyssa? And?
Well, you divide by 7.
Right, well, I have to get rid of that, but there's something else I have to get rid of also.
The negative 12x.
I have to get rid of this as well. In fact, I have to get rid of this first. You have to get rid of everything from the same side. So, we have to add 12x, add 12x. This disappears, and that's how we get it to jump to the other side. So now we have 12x plus 5 equals 7y. The final step's easy. Divide everything by 7. And that's how we get. So, I told you at the beginning that it was going to take you some time. So don't get frustrated. You just got to keep learning from your mistakes. Kamoy and then Nia, and then I got to move on.
I didn't do the plus 12x thing. I just did I divided everything over 7, and it was like that, and I got y equals 5 over 7 plus 12 over 7.
So possibly you just combined a few steps into one? Is that what I'm hearing? That you combined a few steps?
Yeah.
Okay, I'll come look at yours. Ania?
I tried to solve.
Right, and so we're not trying to solve it, right? It takes some getting used to. Takes some getting used to. Okay, draw a line across your paper. Your classwork. Page 29. Number 16, 15, 12, 11, 10, 9, 8, and 7. Go ahead and get started.
You leave at 3:05.